Hi, my name is Dr. Tishan. In this video, we are going to take some derivatives of inverse trig functions. Your formulas for derivatives of inverse trig functions is over on the screen over here. So when you differentiate an arcsine u, you're going to have u prime over radical 1 minus u squared. Note that the derivative of arc cosine u is the negative of the arcsine. Arctangent u, you're going to have u prime of over 1 plus u squared. The derivative of arc cotangent u is just the negative of the arctangent. And then arc secant u prime over absolute value u radical u squared minus 1. The arc cosecant formula is the negative of the arc secant, okay? So there's some connections that you can make to help yourself remember these formulas. We're going to do an example, just two examples. We're going to take a look at, one with a no radical in the denominator with a radical in the denominator. So we're going to look at these two examples, and we're going to find the derivative f prime of x. So example number one, f of x is arctangent x over 2. We want to find the derivative. So this is an arctangent, all right, arctangent. So how do we find that derivative? Let me just remind us here that derivative of your arctangent, all right, derivative of arctangent u is going to be u prime over 1 plus u squared. This is the formula we need to use for this problem right here. Okay? So this is what the formula is. So let's go ahead and see how it works. Okay, so what is our derivative f prime of x for this problem right here? Well, it's a fraction, okay? It's a fraction. Our u quantity is right here. Our u quantity is right here, and it is x over 2. What is the derivative of x over 2? The numerator, I need the derivative of x over 2. The derivative of x over 2 is 1/2, okay? And that goes over 1 plus that quantity u, which is x over 2, and you want to square that quantity. So for arctangent x over 2, what does the derivative look like? It looks like u prime over 1 plus u squared. This is what it looks like. Now we need to simplify that. We don't want to present our final answer as a complex fraction. So let's go ahead and clean this up. So let's go ahead and call this 1/2 over. You have 1 plus, square the x, square the 2. When you square this fraction, square the numerator and square the denominator. All right? This is a complex fraction. We want to clean it up and we want to simplify it. So how can we simplify a complex fraction? The quickest, easiest way that you can accomplish this in one step is to multiply top and bottom. You just want to pick the largest denominator that they all divide into evenly. So in this case, we would multiply the top and bottom by 4. We're going to take this fraction, we're going to multiply it by 4 over 4. 4 divided by 4 is 1. I'm just going to take the fraction. It's just like multiplying it by 1. So we're going to go ahead and do that. So in the numerator, we're going to take half of 4. What is half of 4? Half of 4 is 2. Okay. In the denominator, we do need to distribute. So you're going to distribute to the 4 to each of these two terms. 4 times 1 gives you 4. And then when you distribute to this term, the 4's cancel, so plus x squared. And here is your derivative, written not in no complex fractions, nice and simplified, and this would be your final answer. So to find the derivative of arctangent x over 2, using the arctangent formula, u prime over 1 plus u squared, you're going to end up with a final answer of 2 over 4 plus x squared. So you want to use the formula, and then you want to clean it up and simplify it. So here's your simplified answer. All right? Let's take a look at arcsine. What do you have? So let's, example 2, we're going to find the derivative of arcsine x over 3. So let's remind ourselves, what was that derivative formula again? Derivative of arcsine, u. So that one is u prime over radical 1 minus u squared. Okay, so this is what we need to do. This is the formula that we need to apply to it. All right. So here we go. So what is this derivative going to look like? All right. Well, we want the derivative. Our u for this is it's arcsine u. U is x over 3. What is the derivative of x over 3? It's 1/3. So 1/3 in the numerator, and then the denominator you have 1 minus, and then you're going to take the x over 3 and square it. So this is what, so u prime, your derivative of x over 3 is 1/3 over radical 1 minus u squared. Simplify, it's complex fraction again. So this is applying the rule, but we have to clean it up. We have to simplify. All right, so let's see. Let's go ahead and square the x over 3. We have 1/3 in the numerator. In the denominator, you have 1 minus, this would be x squared over 9. When you square a fraction, you square the numerator, x squared, and square the denominator over 9. Okay? Alright, so what I'm going to do next is under the radical, I'm going to break this down in a lot of steps, okay? So under the radical, let's put this 1 over 1, let's get a common denominator under the radical, alright? We're going to get ourselves a common denominator, alright? So we have 1/3 in the numerator, okay? And then in the denominator, when you get a common denominator of 9, this first fraction is a 1, you got to multiply by 9, so this is going to be 9 over 9. And then here we already have the 9, so minus x squared over 9. Okay, so we're to this step right here. Alright? Alright, so let me go I'm going to travel over here. Okay, so f prime of x. Alright, so let's see where we are. So what do we have here? We have 1/3 in the numerator, so 1/3, we're just simplifying our answer. Alright? The denominator, when you have a fraction under a radical, we can move the radical around the numerator, around the denominator. If you have a fraction under a radical, it is okay to write it like this. Okay? So we have 1/3 over, so the 9 minus x squared over 9 is all under the radical, so I just moved the radical expression so you can see it's around the numerator, around the denominator. So you can see we can simplify here. So what do we have for the derivative? Okay, so we have 1/3 in the numerator, right? The denominator is radical 9 minus x squared over, what is the square root of 9? The square root of 9 is 3, okay? So now when we just simplify our complex fraction, however you want to do it, I'm going to multiply by the 3's, okay? So multiply top and bottom by 3. You can do this, or you can take 1/3 times the reciprocal. Any way you want to work this out, and you end up with your final answer of, let's see, the 3's cancel in the numerator, 1 over, 3's cancel in the denominator, radical 9 minus x squared. So there is your answer as without a complex fraction, okay? So, and this may be acceptable, right? You might have some of your teachers that want you to still rationalize that denominator. So if you do rationalize denominator and multiply by radical 9 minus x squared over radical 9 minus x squared, you could get a simplified answer, or a rationalized denominator answer of radical 9 minus x squared over 9 minus x squared. So here's the expression you would get with a rational denominator, but otherwise you would have this, okay? So using your inverse trig formulas, just be careful with the algebra. Probably want to present your final answers so there's no complex fractions in your final answer. This is how you go through the algebra inside of the calculus, all right? Okay, so hope this helps with some practice with your derivatives of inverse trig functions, and thank you so much for watching. Thank you, and take care.